All right, algebra, we're going to be working on zero and negative exponents. Okay, and the example of what I'm talking about is something like this. Okay, what in the world does 2 to the negative 2 power mean? Okay, and we're also going to be working on stuff like this. What happens when we get 2 raised to the 0? Okay, so those are what we're going to be working on. Now, you guys know that I am an SDSU jackrabbit. Okay, I'm very proud of that fact. And if we went up here, right in Brookings, we have SDSU. Okay, as I frequently like to call it, we have Awesome Town. Okay, SDSU is codenamed Awesome Town. Down here in Vermilion, we have USD. Okay, and USD is what we codenamed as Lame Town. So, if we use Sioux Falls as a dividing line, kind of like a division symbol, anything above here is going to be positive exponents. Okay, because we have a positive feeling. We're in Awesome Town. Awesome Town is positive, so we're in positive exponent territory. Now, if you go down to Vermilion, okay, we have a negative atmosphere because it's kind of lame. So we have negative exponents down here. So there you go. That's my trick to help you remember. Positive exponents go up, negative exponents go down. So if we had an example like this, 2 to the negative 2 power, this is a negative power, this is USD territory, all right? So we're going to put a 1 on the top, and we're going to change it to 2 over positive 2 on the bottom. You see how we took this negative, we made it positive, and moved it down. Now, we can simplify, so we can go 1 over 2 squared, which is 4. And there you go. The reason for negative exponents are simple. It's an easier way to write fractions on like a computer or something if you don't have a pen. Okay? So then we move on to something like this. Negative 9 raised to the negative 2 power. Well, because that's in the negative territory, that's going to Lame Town, USD. So we have negative 9 squared. Well, negative 9 squared is negative 9 times negative 9, which is 1 over 81. And finally, if we had, I mistyped this. If we had 1 over negative 3 to the negative 4th, now here's where the analogy doesn't hold up. If we have a negative exponent, the way you fix it is by flipping it. So these were all on the top and they moved to the bottom. So when you have a negative exponent in the bottom, it's going to move to the top. So we have negative 3 to the negative 4th turns into negative 3 to the 4th, and the 1 moves down. Okay? So we could actually think of this as just negative 3 to the 4th. Well, negative 3 to the 4th would be negative 3 times negative 3, which is 9. 9 times negative 3 is negative 27. Negative 27 times negative 3 would be 81. So this is a positive 81 right there. So there's your answers. If you have a negative exponent, you flip it. We call that using the reciprocal. And then you turn it to a positive exponent. Okay? So it's a little bit like dividing fractions. You flip, and then you multiply. These you flip, and then you solve. So I'm going to pause this, and I want you to try it. Alrighty, so we're back. So here we have a negative 5 to the negative 3. Well, this is going to turn into 1 over negative 5 cubed. And that would be 1 over negative 5 times negative 5 is 25. 25 times negative 5 is negative 125. Well, now we have a y involved, so that just becomes 1 over y cubed. It's heading down to Vermilion territory. And this one here, we have 1 over negative 3 to the negative 2. Well, that has to be flipped into negative 3 to the positive 2, which is positive 9. So, there you go. If you have questions, please ask me. I'm sure I'm just wandering around the classroom right now. Okay, now we have to go back to the lessons we learned in section 1, which means we have to do the addition method. So we have two things multiplied together. We take a step down to multiplication. So we get 6 to the negative 1st. 6 to the negative first has to travel down to vermilion and become 1 over positive 6. Or 1 over 6 to the first, which is 1 over 6. Here, we now have to distribute this negative 2 into each of these, so we get negative 3 to the negative 2 times 2 to the negative 2. That becomes 1 over negative 3 to the positive 2 times 1 over 2 to the 2. So this is 1 over 9 times 1 over 4, which becomes 1 over 36. If you see a shortcut in there, by all means take it. The answer is 1 over 36. Okay, and finally the last one, we have negative 3 times negative 2, which is positive 6. And we have no negative exponents here. 2 to the 6 would be 64. Okay, so I'd like you to try these. So let's pause it and give it a whirl. So we're back. Here we have to drop down to addition, so we get 4 to the negative first, which becomes 1 over 4. This negative 1 times negative 2 becomes positive 2, so we get 3 squared, which is 9. And here we get 2 to the negative 2 times 5 to the negative 2, and that becomes 1 over 2 squared times 1 over 5 squared. This is 4, this is 25. 4 times 25 gives us 1 over 100. Alrighty. I think we're on our last set here. Yep. So here we have 5 to the 0 equals 1. This is a statement I'm making. And actually, I'm going to make anything raised to the 0 is 1, or x equals anything. So 2 raised to the 0 is 1. 2 cubed times 2 to the negative cube is 2 to the 0, which equals 1. And 4 squared times 4 to the negative 2 is 4 to the 0, which equals 1. And I have to ask myself, why? Well, here's why. 4 squared times 4 to the negative 2. If we left the 4 squared on top, that would give us 4 times 4. And if we wanted to move these to the bottom, that would give us 4 times 4 on the bottom, which would be 4 squared over 4 squared. Well, that would equal 16 divided by 16. And we know that 16 divided by 16 is 1. Therefore, if we follow our train of logic backwards, we're brought to 4 squared times 4 to the negative 2. But if we followed our train of logic this way, we're left with 1. And that's going to be true with anything. 2 squared times 2 to the negative 2 is going to end up being 4 over 4, which is 1. Therefore, anything raised to the 0 is 1. And as my very favorite example, Google the number raised to the 0 is 1. Okay? Last ones, I want you to try these. They get about as tricky as I can possibly get. So give them a good try, and then we'll come back and finish up. Alrighty, here we go. Let's see if we can use what we learned. Negative 2 times 4 is going to give us 2 raised to the negative 8, which gives us 1 over 2 to the 8th. 2 to the 8th would be 4 times 4 times 4 times 4, which would be 16 times 16, and I can't quite do that one in my head. It's a little too big. So I would take my calculator out, and 2 to the 8th gives me 256. So our answer is 1 over 256. This one here is a little bit trickier. If we looked at the c to the negative 2, that means that has to be on the bottom because we have to flip it. Well, if we took the d cubed, that has to be on the top. Well, the shortcut here is pretty simple. You just get d cubed over c squared. That's it. You just both flip them both. One went to Vermilion, one went to Brookings. And the very last one, we have to distribute in this negative 2 to each term. So we get 5 to the negative 2 times a to the negative 2. That gives us 1 over 5 squared times 1 over a squared. So that gives us 1 over 25a squared. And there you go. See, fractions aren't so scary, especially when you have exponents involved. Alrighty. The assignment's posted here. It seems longer than it actually is. This here is 2, 6, 10, 12 problems, so you have to get 11 right. And this here is going to be 10 problems, so you have to get 9 right. Alrighty, good luck.